This is our video for CVM 3 about displacement. We'll use the following definition of displacement. Displacement is defined as a change in the position of an object from an earlier position, x initial, to a later position, x final. Bottom line here is we calculated the change in position a lot today. We did that over and over again. This change in position has a name, and that name is displacement. If you're ever asked to calculate displacement, this is what we mean by that. The abbreviation for displacement is the abbreviation for change in, which is that triangle, and the abbreviation for position, which is the letter X. So when we see triangle X, you can either call that delta X, or change in X, or change in position, or you can just call it displacement. And what we're saying is the displacement is equal to the final position minus the initial position. We'll keep track of this as we go. We'll see an example of this. Displacement can be similar to the distance an object moves, but sometimes they're not exactly the same. So we just want to keep that in mind as we go. Let's look at an example of what this actually looks like in the real world. You can see this is taking place in our hallway, and we set up a number line here where this is the position equals 0 reference point. We've got a positive direction in this direction. This is a little hard to see, but this is a plus sign with the arrow pointing this way, so the positive numbers are going that way, and this is a minus sign, so this is the negative side of the number line. You can say Mr. May is actually standing in the positive part of the number line. His position is positive. Coach B's position is negative, but the object that we're really going to focus on here is the ball. So check out what happens to this ball. Coach B's holding the ball here, and he does a quick chest pass in slow motion to Mr. May, and then Mr. May catches that ball. We are going to keep track of the position as that ball is passed, and you can tell that Mr. May is really excited about this for our sake. So let's check this out. If we want to keep track of the position of this object, we need to make a representation of this number line. So let's just draw it as best we can. We want to start with a 0 point. Then we're going to add some positive numbers. We could say this is 1 meter in the positive direction. And then most of the action here takes place in the negative direction. I'm going to call this 1 meter, and we'll call this 2 meters. We'll say Coach B starts with this ball, and we need to figure out what the initial position of this ball that is being passed here. Because we want to say X initial, the initial position, equals what? Well, let's look at the video and we'll see. If this is our 0 point, this is 1 meter in the negative direction. You can see this says -1. And then this is -1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, -1.8 meters until the right side of the ball. Remember, we have to keep track of which side of the object we're thinking about. So we're going to say it is -1.8 meters to the right side of the ball. We'll say X initial equals -1.8 meters. If we then, sorry, let me leave that there for a second. X initial equals 1.8 meters. If we then play this video again, and I'll be careful to pause it when Mr. May catches the ball, we can see it's moving and then it's caught. We need to figure out what the final position after that pass is. Again, we're not interested in the left side of the ball. Obviously, it has a different position than the right side. We need to look carefully. What is the position of the right side of this ball? It looks to me like this is exactly at 0. So we're going to say, after Mr. May catches the ball, let's draw Mr. May here. He has caught the ball, and we'll say X final equals 0.0 meters. Our next job is to calculate the displacement of the ball from this initial position to this final position. And we'll continue this example down here. So let's start with our general equation. We're going to say displacement equals, I'm going to write this out with words. If you would prefer to write it out with abbreviations, you can, if those abbreviations make sense to you. I'm going to write it out with words just so it makes sense to everybody completely. So I'm going to say the displacement equals the final position minus the initial position. The displacement in this particular example would be the final position is 0.0 meters minus negative 1.8 meters. We saw this in class. We want to keep track of the subtraction that we're doing and the negative sign. We got to keep track of both of those things. So the total displacement here equals positive 1.8 meters. Now, this is saying that even though the ball is in the negative region the entire time and reaches the 0 point, that is the right side of the ball reaches the 0 point, the displacement, that is the change in position, is positive. If we look at this drawing, we can say that this change, this displacement, we could call delta x, that is the change in position, the displacement, equals positive 1.8 meters. Annotating that change, I'm going to actually do that so we know what that refers to. Annotating that change helps us realize that this is correct. Sometimes if we make a mistake with our negative signs